A warm afternoon to all my dear lovable 7th standard students. Today you are going to attend science class. I hope you are all watching the video classes properly. Keep watching, children. Let us start our today's session. Before going to start the lesson, I wish to give some general information. Look at the picture, children. Today we are going to learn why are we unable to walk straight and tend to lose our balance when we walk with our eyes closed. Children, when one wants to walk in a straight line, the brain takes a visual reference point and uses this reference point to maintain the movement in a straight line. Okay? In the absence of a visual reference point, the brain is unable to ascertain the exact direction in which the body is moving, and hence most of us will be unable to walk in a straight line with our eyes closed. Okay. However, visual reference is not the only mechanism of maintaining balance or direction in our movements. We can judge the direction of movement very accurately with the balance sense from the balance mechanism in our inner ear and by kinesthetic sense, which is sensations we derive from our muscles, joints and ligaments. Okay? Both these sensations will tell us very accurately as to the balance and direction of movement and position of the body and any point of time. Okay, this is highly developed in acrobats, gymnasts and ice skaters. Okay, they would be able to walk in a straight line even with their eyes closed. With this information, let us start our today's session. Children, last class we discussed the lesson on the title Chemistry in Daily Life, isn't it? Today also we are going to continue the same lesson, so be ready. Let me give a quick recap we learnt in the last class. Children, last class we discussed about antibiotics, analgesics, antipyretic, antiseptic. Then we discussed about antihistamine and medicines. Do you all remember that, children? Shall we start the today's session? Children, today we are going to learn the next topic, combustion. Children, can you guess what is common in rusting of iron, burning coal and the flame of candle? Yes, they all undergo a chemical reaction known as combustion. Okay, combustion is a chemical reaction that occurs in the presence of a fuel, okay, and an oxidizing agent that produces energy, usually in the form of heat and light. Okay, so children, burning of substance in air to give out heat and light is called combustion. Okay. Children, burning is really a combustion reaction. In fact, combustion is one of the first chemical reaction intentionally harnessed by humans. Any reaction that involves reactions with oxygen is called oxidation reaction. Okay. In the combustion of hydrocarbon with oxygen, typically carbon dioxide and water are produced. Okay. Yes, hydrocarbon reacts with oxygen, gives out carbon dioxide, water and heat energy. Okay, children, all combustion reactions are exothermics, that is, they release heat. Okay. Next, we are going to discuss about ignition temperature. Children, the minimum temperature at which a substance catches fire and burns is called its ignition temperature. Okay, a substance will not catch fire and burn if its temperature is lower than its ignition temperature. Okay, different substances have different ignition temperature. Okay, children. Children, substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. Example, petrol, alcohol, LPG, that is liquefied petroleum gas, then CNG, that is compressed natural gas. All these are example for inflammable substances. They can easily catch fire. Okay, children. Children, next we are going to discuss about flame. Look at the picture, children. Children, when you light a candle, the heat melts the wax and molten wax rises up the wick, vaporizes and then burns, isn't it? When vapors burn, a flame is produced. The region of burning gases is called a flame. Okay, flame is actually a chemical reaction. To be specific, the flame is a mixture of gases, that is vaporized fuel, oxygen, carbon dioxide, carbon monoxide, water vapor and many volatile materials. Okay, and so is matter. The light and heat produced by the flame is energy, not matter, but fire is a matter. Okay, children. Children, next we are going to discuss about flame and its structure. Children, which is a festival of light? Yes, you are correct, Diwali, isn't it? What is the speciality of that festival? Yes, we will light more lamps to decorate the houses, isn't it? Yes, now how do the lights glow? Yes, with flame. Okay? Yes, look at the picture, children. Here is an experiment with colorful flame. White flame is formed by Epsom salt. Violet flame is formed by lithium chloride. Indigo flame is formed by potassium chloride. Blue flame is formed by bleaching powder. Green flame is formed by borax powder. Yellow flame is formed by calcium chloride. Orange flame is formed by table salt. And red flame is formed by strontium chloride. Okay. Next we are going to discuss about flame. Flame is a zone of combustion of a combustible substance. Substances which vaporize during burning produce flame. Example, wax and kerosene. Okay, substances which do not vaporize during burning do not produce flames. Okay, example, coal. Okay, children. Children, next we are going to discuss about structure of a candle flame. Look at the picture, children. A candle flame has three main zones. They are the outer zone, middle zone and inner zone. Okay. First we are going to see the outer zone. It is the outermost part of the flame. Okay, where complete combustion of the fuel takes place. And the color of the flame is blue. Look at the picture, children. Yes, and is the hottest part of the flame. Okay, it is the non-luminous part of the flame. Okay, children. Next, we are going to discuss about the middle zone. It is immediately inside the blue zone. Partial combustions of the fuel takes place. Okay, and the color of the flame is yellow. Okay, and is moderately hot part of the flame. Okay, it is the luminous part of the flame. Okay, children. Next, we are going to discuss about the inner zone. Okay, it is the innermost part of the flame, close to the wick. Okay, where unburnt wax is present, and the color is black. Okay, and is least hot part of the flame. Okay, children. Look at the picture, children. Yes, this image shows the structure of a candle flame. Yes, so the outer zone of complete combustion takes place in blue flame. It is the hottest part, and middle zone of partial combustion takes place in yellow flame, and it is moderately hot, and innermost zone of unburnt wax vapors is black color, and it is the least hot part of the flame. Okay. Next, we are going to discuss, do you know, given in your textbook. A candle flame is caused by vapor burning above the candle, isn't it? This burning vapor is hotter than the surrounding air and is therefore less dense. So, by the principle of convection, it rises. So, the flame is always upwards. Okay, children? Next, we are going to discuss about calorific value of different fuels. See the tabular column, children. Yes. So, the cow dung cake have 6,000 to 8,000 calorific value. Then wood have 17,000 to 22,000. Then coal have 25,000 to 33,000. Petrol have 45,000. Then kerosene have 45,000. Diesel have 4,50,000. Then methane have 5 lakh. Then CNG, that is compressed natural gas, have 50,000. Then LPG have 55,000. Then biogas have 35,000 to 40,000. Then hydrogen have 1,50,000. Okay. Children, now we are going to discuss about calorific value. The amount of heat energy produced and complete combustion of 1 kilogram of fuel is called its calorific value. Okay, the calorific value of a fuel is expressed in a unit called kilojoule per kilogram. Okay, calorific value equal heat produced divided by amount of fuel. Okay, used for burning in kilojoule per kilogram. If 4.5 kilogram of fuel is completely burnt and the amount of heat produced stands measured at 1,80,000 kilojoule, then how to calculate the calorific value? Yes, calorific value equal to heat produced is 1,80,000, isn't it? Then the amount of fuel used for burning is, that is 4.5. So, if we divide 1,80,000 divided by 4.5 means we will get 40,000 kilojoule per kilogram. Okay. Children, next we are going to discuss about types of combustion. There are 3 main types of combustion. Okay, they are rapid combustion, spontaneous combustion and explosion. Okay. First, we are going to discuss about rapid combustion. When a substance burns very quickly when ignited, it is said to undergo rapid combustion. Okay, and produces heat and light with the help of external heat, that is with the help of any matchbox, with the help of any candle or any other flame. Okay children, so example for a rapid combustion is burning of LPG. Okay children. Children, use of a gas lighter to ignite the LPG gas stove shows how LPG undergoes rapid combustion. Look at the picture children. So burning of LPG is the example for rapid combustion. Okay. Next we are going to discuss about spontaneous combustion. What is spontaneous combustion? When a substance undergoes combustion without an external source of heat for starting it, then it is said to undergo spontaneous combustion. Can you able to understand children? Without any external heat, that is without any matchbox, without any candle, without any other flame, the substance started to burn. Okay, so example, phosphorus burns spontaneously at room temperature. Okay children. Children, next we are going to discuss about explosion. What is explosion? It is a type of combustion in which a substance burns suddenly and produces heat, light and sound with the help of heat or pressure. Okay, so example for explosion is explosion of crackers. Okay, so carbon monoxide leads to respiratory problem and carbon dioxide causes global warming and sulfur dioxide and nitrous dioxide cause acid rain. Okay children. Children, it's time to recap we learned in this session. In this session, we discussed about what is combustion, then we discussed about ignition temperature, then we discussed about flame and structure of a candle flame, then we discussed about calorific value of different fuels, then finally we discussed about types of combustion. Okay. Children, here I would like to end up this session with this topic. Next class I will meet you with the new topic. Until then, thank you.